Hello, 5th graders. This is Miss Sterner. Today we're doing Eureka Math Module 5, Lesson 6. Our objectives today, content, is I can find the total volume of two non-overlapping rectangular prisms, and the language objective is I can explain in complete sentences my strategies for finding the volume of solid figures. So we're going to start with an application problem today. So you'll need a piece of paper and a pencil. So it says, a storage company advertises 3 different choices for all of your storage needs. The cube, a true cube with a volume of 64 meters cubed. The double the volume of the cube. And the half the volume of the cube. What could be the dimensions of the 3 storage units? How might they be oriented to cover the most floor space? And how might they be oriented to create the most height? So, you should pause your video so you can try this on your own and come back when you're ready to check your answers. So I'm going to go on to checking the answers. So I've already done this problem, and I'll show it on my camera here. So we need to find the volume of each of those storage units. So to find volume, we have length times width times height. So I'll start with the cube. Okay, so we see a cube. We know it's 64 meters cubed. I used my knowledge of cube numbers and tried out 4. So 4 times 4 times 4 does equal 64. So I did 4 times 4 equals 16, and then 16 times 4 equals 64. Okay, then we go on to our double. So the double is 2 of the cube. So I drew it here, and so we have the dimensions that are the same but stacked up. 4 plus 4 equals the 8 meters for the height. Okay, so then I did the math to support it, to check my answer. So you can see that we had 64 meters cubed here, so you have 2 of them, so add them up, 64 plus 64, and you get 128. Or you could multiply it. 4 times 4 is 16, and then 16 times 8 equals 128. Okay, then we did our half. So our half is going to be like the cube, but you just slice it in the middle. Okay, so I have the same dimensions for 2 of them, but we had to cut 1 in half, so half of 4 is 2. And then the volume would also be half, so I divided 64 meters cubed by 2 to get 32 meters cubed. And then to do the math to prove it, we have 4 times 4 is 16, and 16 times 2 equals 32. Okay, and then they asked us to orient these storage spaces to cover the most floor. So if you can imagine, you have your cube and your other cube, and then you just put this double on its side, and that'll cover the most floor. Then, if you wanted to cover the most height, you just stack them all up. So we have our double standing up as tall as it can, and then we'd have to put our cube up there, or you could put your half, but you need to move the half to stand up to make it as tall as it can be to create the most height. Okay, so we're going to flip back to our slides. Okay. Now, for our lesson, I will be going back to the camera, and we're doing the problem set on pages 35 and 36. Okay, so when you do get to your independent practice, that will be from the homework pages. So you'll need your math book and your pencil for this. Okay, so we're not going to do all of the problems because I think we have some very similar problems. So we're just going to do a couple of them as examples. So we're going to do 1A and 1D. And then I wrote the formula up here again to remind us. Volume equals length times width times height. Okay, so it says find the total volume of the figures and record your solution strategy. So we see that we have 3 centimeters here, 14 centimeters here, and 5 centimeters here, but they're stacked up. So we have 5 centimeters and 5 centimeters. We can just add that up. 5 plus 5 equals 10 centimeters. Okay, and then we'll just have to multiply them to get the volume. So 3 centimeters times 14 centimeters times 10 centimeters. Okay, I think I'm just going to start off with 3 times 10. We know that's 30. So we'll have 30 times 14. And so 30 times 4 is 120. Put my place value. Then 1 times 0 is 0, and 1 times 3 is 3. We'll add it up, and we get 420. So the volume is 420 centimeters cubed because we did our volume. And if we want to explain in words, we can say I multiplied length times width times height to equal volume. Okay, so if you need more time to write these things down, you can go ahead and pause. I think it'll still show, yeah, on my screen. So we'll do D, and so we have 2 figures that are not exactly the same. So we can see this bottom one. I'll do bottom, B for bottom. Okay, it's 10 meters and 3 meters and 6 meters. Our A, you don't have to label it that way, but I just think it's much more clear when you're doing your calculations if you have them labeled. So our side length is a total of 12 meters. We know that 6 of it belongs to B. So we just subtract 12 minus 6, and we'll find that our top one is also 6 meters. So I am going to label this as 6 meters. Okay, so now we have our dimensions for each of them. So A, we have 8 meters, and we're using our volume formula for this. 8 times 6 meters times, and then we had 3 across because you see these are the same. 3 meters. So I'm just going to multiply my 8 and 6 together, and then I'll get 48 meters times 3 meters. Okay, and so we have 3 times 8 is 24. Carry our 2, we have 3 times 4 is 12 plus 2, we have 144 meters cubed because we found out the volume for A. Okay, and then here, B. So we have our 6 meters on the side, and we have 10 meters on the bottom, and then we have 3 meters there. So I'm just gonna go with 10 times 3. We know that's 30. And then we have our 6. Multiply that. So we have 6 times 0 is 0, and 6 times 3 is 180. Well, it's 18. The total is 180. And then we found our volume, so that's meters cubed. Okay, so to find the volume of the entire figure stacked up as they have them, we just have to add it together. So we'll add our A, 144 meters cubed, plus our B, 180 meters cubed. Okay, and I will do that vertically here to show you. So 4 plus 0 is 4. 4 plus 8 is 12. 1 plus 1 plus 1, we have is 3. So 324 meters cubed. Okay, so we're going to turn the page. If you need more time, feel free to pause the video so you can write down everything you need to write down. I'm going to turn the page. Okay, so problem 2 we're not going to do, but it's very similar to what we just did. They give you the dimensions, and you just need to figure out the volume for each of these and then add it all up to find the total volume of that sculpture. Okay, so we're going to do number 3. It says the combined volume of 2 identical cubes is 128 cubic centimeters. What is the side length of each cube? Okay, so key information. I have 2 identical cubes, and they're 128 cubic centimeters combined. And we need to find out what the side length of each cube is. So, start with drawing a cube, because this is a word problem. We're going to do our redraw, write. So, I have our cube. And I will try to draw another one as close to identical as I can. Okay, I think that's pretty good. Okay, so we know that they are identical. So they're the same. We can just divide 128 cubic centimeters, because we know that's how much their volume is altogether, by 2. 12 divided by 2 is 6. And then we have 8 divided by 2 is 4. And if you remember our application problem, this is just about the same as the cube in our application problem. So if you remember, the cube had 64 meters cubed as its volume. This is 64 centimeters cubed. So same number, different unit of measurement, but 4 times 4 times 4 is still 64. So That means instead of meters, we have centimeters. So we will have 4 centimeters and 4 centimeters and 4 centimeters. Okay, so let's get our sentence on there. We're going to use our question as a sentence frame. So the side length of each cube is 4 centimeters. Okay, so we have our read, draw, write. Okay, wrote our equation and wrote our sentence. Okay, we're just going to do one more. We're going to do the volume here on number 4. A rectangular tank with a base area of 24 centimeters squared is filled with water and oil to a depth of 9 centimeters. The oil and water is separated into 2 layers when the oil rises to the top. If the thickness of the oil layer is 4 centimeters, what is the volume of the water? Well, it works like that in real life too. If you put oil and water together, the oil is going to rise to the top. So you can try that on your own to prove it and think about why does that happen? And then you can talk to your parents about that. Or if they're not around, you can search it up yourself after you have thought about it. Think about it first. Okay, so anyway, rectangular tank with a base area of 24 centimeters squared. Okay, I see that centimeters squared. I think, that's area, isn't it? Okay, so then I have the water and oil has a depth of 9 centimeters. So here's our, first we have, here's oil on the top, and here's water on the bottom. So we have our water and our oil, and they tell us it's 9 centimeters. So the thing is, they want us to find out, it says, what is the volume of the water? So it's nice that they give us this information about the oil because it's going to help us figure out information about the water. So if we subtract this 4 centimeters of oil from the total 9 centimeters of water and oil, we will get 5 centimeters of water here for our height. So volume is length times width times height. Area is length times width. So pretty much volume is area times height. So that's what we're going to do. We want volume of water equals 24 centimeters squared times 5 centimeters. Okay, sorry if that went off the edge and make it a little bigger there. Okay, so I like to multiply vertically and add vertically too. So we have 5 times 4 is 20. 5 times 2 is 10 plus 2. And so then we have 120. And then we did volume, so that's centimeters squared. So all we need to do now is just write a sentence. And we'll use our question, what is the volume of the water, as our sentence frame for answering our question. So the volume of the water is 120 centimeters Okay, I think it's important for us to write the sentence because it helps our brains explain what we've done. Like, you may say, oh, well, I already get it, I don't need to write the sentence. But then if you're trying to explain it to someone else because you're trying to help someone else, if you think about it and you're able to put it into words, then you're going to be able to help the other person better, and it's going to make it more clear in your own mind as well.